Hi, Shiley. Hi,
Don't
Gabby.
you record? Do you record that?
Do you like Shiley?
I can always edit.
Because I feel like I listened to one of those and it wasn't like I couldn't.
How long does it take you to edit one of
in the
these?
background. Like you recorded your voice.
I recorded my voice again.
She probably has like a
It
secret
sounded-
microphone.
I don't know.
You should just put one of those microphones on your like.
Okay, let's just start because I don't care about this.
It's last period on a Thursday, and I don't want to learn, but I'm going to learn and I'm going to be quiet. So can we all just pitch in and be quiet and learn?
Yeah.
That was a really inspirational speech.
Okay,
Still.
so we are going to do two theorems today. They're inequality theorems, so we don't need to worry about proving them. Okay. The first one is called the hinge theorem, and actually these two theorems go along together. Basically, this is when we know two sides and the included angle. Included angle. That says included if you can't read it. Okay. So basically what we're saying is the two sides are actually congruent. Okay, but the angle in between is not congruent. So we have two sides of one triangle are congruent to two sides of another triangle. So right here, like here's AB and PQ, Henry,
Is this always down?
and AC and PR are congruent. Okay. So basically I have two sides that are congruent. However, one angle in this triangle is bigger than the angle in the other triangle.
Oh.
So what does that tell us about the opposite side?
That it's not congruent.
Smaller.
Okay, so if the first angle,
So
so
then
here's
BC.
angle 1. So if angle 1 is bigger than angle 2, that makes the side opposite
BC is
larger than the side opposite angle 2. So QR is going to be smaller. So BC is greater than QR.
If two
Okay.
sides are
Okay, the reason we call this the hinge theorem, it's kind of like opening a door. Think about opening a door. So the door itself is not changing.
Oh, I
Right?
get this.
It's not changing any size, but obviously the bigger the angle, the more we open the door, the more space there is. Right?
Yeah.
So this is taking two sides. So imagine it working just in one triangle. So here are your two sides. If you make that angle smaller, what happens to the opposite side? It gets right. It's getting smaller. And what if we opened it up more?
Gets
The side gets bigger. So think of something on a hinge. So the smaller angle
Oh, I get
makes
it.
it the smaller side. The bigger angle makes it the bigger side. They're always directly across from.
Yes.
Okay. So side, side, side inequality. Side, side, side inequality is basically the converse. So this is when we have two congruent sides and one side not congruent to other. Okay, so here's my picture. I'm going to say AB is congruent to PQ and AC is congruent to PR. So again, we have two sides of one triangle are congruent to two sides of the other. So now I'm basically saying the last one was side angle side, so it's like we had two sides that were congruent and we were talking about the angles. Now what happens if we know BC? So what if BC is larger than QR? What does that tell us about the angles? So Corey?
Angle 1 is greater than angle 2.
Right, so measure of angle 1 is greater than measure of angle 2. Now, Before we go on to the next example, I just want to talk about a few things. When we have inequalities, we need to make sure that our angles never get too big or too small. In other words, we're never going to talk about negative angles in this class. Later in Algebra 2, you do get to learn about negative angles. But because it's in reference to a triangle, we want to make sure that even though angle 2, right, is smaller than angle 1, we always want to make sure that the angles, sorry. We want to make sure that our angles have to be greater than 0 degrees and less than 180 degrees, okay? We don't talk about angles that are larger than 180 degrees again in this class, because again, everything references back to the triangles themselves. So when we do our first set of inequalities, we'll have one where we're going to compare like the two angles, but we always want to make sure that there's also that other restriction. We want to make sure that we don't end up with a negative angle measure or an angle that's greater than 180 degrees. So on the above one, in terms of sides, whenever I'm comparing sides, we just want to make sure that sides, the side measures, are greater than 0. They can get as large as possible. We don't have that restriction about making sure that the side has to be less than 180, okay? Because we're not measuring in degrees. Jacqueline, you had a question?
Yeah. So, wouldn't, if an angle is greater than 180 degrees, wouldn't it be like, if like this is the angle,
Right.
this become the angle?
Okay, so there are angles that are bigger than 180 degrees,
But doesn't
but not.
doesn't the other side just become the angle, like this?
But we can't refer to an angle measure greater than 180 degrees inside of a triangle. That does not make sense. Now, when you talk about greater than 180 degrees, yes, what you just said is true to a certain, you're talking about something completely different. Then we get involved into reference angles and other things. And they could be acute or obtuse depending on how large your angle gets. That's like a kind of precursor to what you learn in Algebra 2. Okay, let's start with example 1. Write inequalities using the information in the figure. Okay, so first thing we want to do is we want to compare two angles. We're comparing QSR and QSR is here and QSP. So before you even do that, it's best to label the sides that you have congruent. Because sometimes we have like a lot of information that we're looking at. So I know obviously these two sides are both 12, so they're congruent. And they share a side. So I'm really comparing the included angles. So you see 46 degrees here?
Yeah, 46.
So here's 46. This is not the same, so I'm just going to put two arcs. And we have this angle is 5x minus 14. So how do these two, how does...
QSP is smaller.
QSP
How do you know?
is less than angle QSR. So if you...
To write the M.
So if you look at
I'm
QSP...
confused because you write angle and then you write like the greater or less than sign and they look the same.
Oh, it looks the same, yeah.
So I don't know how to like, when I'm like doing homework or whatever, I don't really know what to write to like.
To distinguish it.
Yeah.
I mean, it's okay. I mean, I'll be able to tell by what you write, but usually I make the less than just a little bit smaller than my angle symbol, but I know what you're saying.
So
Okay, so how do we tell? So we look at the opposite angle. So I look directly opposite of 46 degrees is 15. And right, the opposite side. So opposite to angle QSP is 14. Since this one is smaller, that means the angle has to be smaller. Okay, that's that hinge theorem. So you have the two congruent sides. So you're kind of looking at, all right, what does that tell us about the angles? Now, find the range of values. So we just said measure of angle QSP, which if you look in the picture, that's 5x minus 14. That's going to be less than angle QSR. 46. Now, what do we have also to include? So remember, so this is going to be 46. This angle has to be greater than 0 also. So I'm going to put here and 5x minus 14 has to be greater than 0. So when we're working with, okay, you have this angle is less than this one, but we already know 46, right? Right, you know, remember how I said angles can't go beyond 180 degrees and we don't want them to be less than 0. Well, if you're already saying it's less than 46, then you just need to make sure that it's greater than 0.
So you're equal.
Okay, because you don't want to end up with a negative angle measure. Does that make sense, or is that a little confusing? Okay.
So
got the
it's pretty much
answer.
that 0
It's
is
14 over
less than.
5 is less than x, which is less than 10.
Okay, so we get, okay, let me just go through it. So what do we get? X is less than 12, and
Oh, I did the math wrong.
5x is greater than 14, so x is greater than 14 over 5. So you can write your answer like this, or you can just put 14/5 less than x less than 12. So that's your range. So basically, anything, you can have anything between 14/5 and 12. So this kind of goes along with what we were looking at yesterday, but in this problem, it's referring to the angles. Okay, Tom?
So just keep it. Wait, so you're saying it's not a big deal if we just keep it at x is less than 12, and
And x is greater than negative, or 14.
it's not a big deal. Yeah.
What do we put on? what
Oh,
do
you
we put on-
don't have to write it this way. If you just want to leave it with the word and, that's fine.
Yeah. Makes more sense.
Oh, do you need that still?
Okay. Next.
Okay, the next one. Okay, so I see these sides are already congruent,
Kind of the
Quick
same
question
thing.
about the one before.
and they share a side.
Same
So I'm looking at this angle and this angle, right?
GHE is
And I'm
greater.
looking at their opposite sides. So write an inequality to compare measure of angle JHE and measure of angle GHE. So GHE,
is less than JHE.
okay, or measure, it doesn't really matter how you write it. You can write it JHE is greater than measure of angle GHE, or GHE is less than, same thing. Now we're going to find the range of values containing x. Okay, so GHE is 6x plus 15, and that has to be greater than GHE, which is 65. Okay.
Less than 180.
Very good. So, remember I told you that we have to make sure, you're basically going to use one of them. Whenever you work with angles, you're either going to have to make sure it stays greater than 0 or less than 180, but that depends on your actual, if it's greater than 65, isn't it automatically going to be greater than 0?
Yeah.
Yeah. So we just have to make sure it doesn't get too big. Make sense? So we have to add the restriction with 180.
Wait.
No?
My
No,
question
it
is
just doesn't.
no. My question is why on this one we had, on the one before we had to do 0, but this one we didn't.
Yeah, what's
Okay.
that was
It's
called?
because
It's because it's greater than.
So this last one was less
Oh.
than 46. So automatically it's less than 180. Okay?
Oh, yeah.
So then we just have to, you
See,
choose one or the
Oh.
other. So if it's less than, here, let me write that down. If your angle is less than a number, then you have to also make sure the angle is greater than 0. But if it says the angle is greater than a number, then you have to throw in there the angle must be less than 180. Okay? These are like case 1, case 2. So we got a number here, right? An actual 46. That's when I say number, you know what I mean? Like you actually have the angle measure. So the angle, when it's less than the number, you want to make sure it's greater than 0. And then if it's bigger than that number, you just have to make sure it's less than 180.
Bigger
Now,
than
does that
the
kind of
opposite
clear?
number?
Oh, Jordan?
If 5x minus 14 was less than 46 and you do 5x minus 14 is less than 180.
If this had a greater than 46,
Yeah.
then you would say less than 180.
And then you just solve for
Oh, so you see where the x is? You have to see if the x is bigger or less.
That's what I said. Here, if it's less than, if the part with the x is less than, then we have to make sure that's also greater than 0. If it's greater than, we have to make sure it's less than 180.
Okay.
Would you prefer
We'll
an
do some more
improper
examples.
fraction?
Okay, so,
Would you prefer an improper fraction?
yeah.
Okay.
Okay, 65 minus 15 is 50. So 25 thirds. And let's look at the other part. So 6x less than,
165.
and then when we and dividing, yeah, 50. Wait, what is it? 165 over 6 is divisible by.
It's 27 and a half.
But she wanted it improper.
Oh, it doesn't matter. Mixed number or improper. 27 and a half. So if you want to write this one as
Or 55 over 3.
or 55 over. No, it can be over 3.
No, it wouldn't be over 2.
No, I think it's,
Corey, how can you over
Hold on.
Because
Wait, no, he's right. He's right.
no, it's 55 over 3, not
Yeah,
over
55
2.
over 3 is right.
Calculator.
It's over
How about
3.
over 2?
It's not over 2.
It's 165
How would it be over 2?
Because 165 is
It's
divisible.
not divisible by 2.
It's divisible by 3. So you shouldn't have a 3 in the bottom.
Oh, yeah.
You should have a 2 in the bottom.
yeah.
Is it
Oh,
27
that's
and a half?
I apologize.
That's one.
Sorry.
Yes, I verified that it is.
Alright,
2 more.
Okay, let's look at the next one. Now, there.
It's 60. The angle is 60.
Right, so if you look at the triangle on the top, it's equilateral, which makes all the angles. That's my phone.
Equal.
Yeah, I thought it was
60 degrees.
What is 60?
Okay.
Do you need to answer that?
No. I was worried it was the kids' school, but it's not. We're safe.
The what?
My kids' school.
So
Are they
one
going to school?
x plus
Are
5
they gonna go
is
here? Are they
is
twins?
greater than 3x minus 7.
Okay, so wait, which two sides are we, this is a tricky one, guys, so we need to really be careful how we look at this. So we have to kind of figure out which two sides remember, you always have to have two sides congruent in order to use this hinge theorem. So I have this side and this side, but
So that means that the corners
now
are
it doesn't
60
really
degrees.
matter because if it's equilateral, all the sides are x plus 5, right? Don't you agree?
Corey, no.
So I can compare these two sides. Now, when I compare,
Wait, why?
look, it doesn't matter. It doesn't matter which two sides from the equilateral triangle we choose because they're all the same. They're all x plus 5, right? X plus 5, x plus 5, x plus 5. Here, I have to see how 3x minus 7 compares to x plus 5. Now, 60 is bigger than 45 degrees, right?
Go with the top one.
So the side opposite, right? Look here. So x plus 5 must be bigger than 3x minus 7.
True.
Okay, this one's smaller.
Does it matter which side you
Okay,
use?
what's that? So
Because
x
it's the same inequality.
x has to be smaller than 6.
Okay, so 3x minus 7 has to be less than x plus 5. Let's hold off on the other inequality for the moment, okay?
X plus.
Let's just hold off on that. Let's just subtract x. We get 2x. Let's add 7 at the same time. So we get 2x is less than 12. X is less than 6. Now, that's only half of my inequality. So if x is less than 6, now here's where it gets challenging. The rule gets a little more complicated. I have to make sure that x doesn't get too small. I got to make sure that it doesn't become a negative value. So the problem is I have two expressions here. I have an x plus 5 and a 3x minus 7. Which one do I need to make sure stays greater than 0?
3x.
The 45.
The 3x minus 7. Why do I want that
Because
one?
it's a
That's the
smaller
smaller
one.
Of
I'm
course.
very confused.
Me too.
Me too, I just guessed.
No, it's because
Okay,
the
go ahead, Corey.
well because
If
if x plus 5 is greater than 3x minus 7, then if 3x minus 7 is greater than 0, x plus 5 is greater than 0.
Wait, say that
Okay.
again?
Yeah.
this one is bigger, right?
Yeah.
This one's smaller.
Yeah.
So I have to make sure that the smaller one is
Equals
bigger
it.
than 0. Because
Oh,
automatically,
I get.
the bigger one will be forced to be bigger than
So
0.
that means x is greater than 7/3.
Think about that. If I just make sure that the bigger one stays greater than 0, does that make the smaller one necessarily bigger than 0?
Well, they're both bigger than 0.
Well, I know, but which one do I need to use? I need to use the smaller one.
If you use the bigger one,
I'll see if I can.
Jordan,
That's less than.
Jordan,
I have
if
a
you
question, Mrs. Casey.
Jordan, if you
For
have
the last
5
one.
and 3, and you need to keep the 3 above 0.
Just a minute,
You
Ethan.
can't subtract 5 because if you subtract the 5,
Yeah,
the 3 is going to go below.
Wait, what?
Yeah.
That just confused me.
Just ignore the sex.
So is the way I wrote that still terrible?
Don't tell yourself that.
Really?
Is 180 degrees
Okay.
angle the same as a 0 degree angle?
Okay, I guess.
Very good.
Kind of.
Yeah, kind of. Okay, what is the shortest segment in the figure? This actually relates back to something that we did with the previous lesson.
That's wrong.
So,
I want to say AC, but it's
No, it's not because the 60 degrees.
okay,
It's a
so
I know that.
compare each. I'm looking for the shortest.
BC.
Now,
No.
okay, guys, think about it before you just call out. So, look at each triangle. So, here's 50 degrees. So, this would be the smallest,
It's DC.
right?
Nice,
This
huh?
one, right, is that makes this one the smallest.
But then there's also the 60. Yes.
Okay, but wait. It's not the smallest in this triangle.
Do you always
This
go with the larger
triangle,
one?
it's the middle side. So if this is the middle side, and we just said this was the smallest of the triangle on the left,
So it's
this one is the smallest, it's
Which one?
DC.
What?
That's what I was gonna
You
say.
ever understood something for like a quarter of a second and you're like, wait, no, I don't
Wait, why is
understand.
that?
Okay. This is the middle side. You have to compare
To both of the.
to both of them. See how these are kind of like battling
Homework.
against each other here?
The
It's
bigger
the
one
smallest
is
one here,
short.
but it's the middle one here. So if
smallest
this
one is
triangle
there.
has something smaller than its middle side, this is going to be smaller.
Last assignment of the
Out of
year.
curiosity,
Okay.
why isn't it AB?
Can I,
I don't get it.
do you want me to show you with numbers?
Yes.
Wait, why
Wait,
wouldn't
can
it?
we just go?
Yeah, let's do the homework.
Yeah, well, yeah.
If
Let's
you
just do the homework.
you just want to do the homework?
Yes.
Yeah, let's do the
Okay.
homework.
Obviously,